Okay, so I put a problem up here that is based on weight again. Now, I realize I made a big deal about kilograms being mass and not weight, but remember, we're going to use them interchangeably. So we're going to go ahead and we're going to find the dosage for this patient. This patient is 88 pounds, so our first step is always going to be to convert that into kilograms. So 88 divided by 2.2 is going to be 40 kilograms for our patient. Now to get a dosage here, we're going to take that weight of 40 kilograms. And up here we have an equivalency of 0.5 milligrams per kilogram. So that means 0.5 milligrams is equivalent to 1 kilogram of body weight, body mass. So getting rid of kilograms, the kilograms go on bottom, milligrams on top, 1 kilogram to 0.5 milligrams. So the kilograms are gone. But next we have 25 milligrams in 8 milliliters. So I'm going to put milligrams on bottom to get rid of them. Going to 8 milliliters. So 25 and 8. Milligrams are gone. So now we can find how many milliliters we would administer to that patient. 40 times 0.5 times 8 milliliters is 160 milliliters. 1 times 1 times 25 is 25. What does that come out to be? 6.4 milliliters. Now that's not the whole story. Remember, we had this time limit up here of 4 hours. So what that is telling us is that we can administer 6.4 milliliters every 4 hours. So those dosages based on weight are pretty simple to calculate. There's something that we'll call a titration. And a titration is when we're given, rather than given just a single dosage like that, we might be given a range. Or we might be told that the safe dose is 1.5 milligrams to 2 milligrams per kilogram every 8 hours. And let's say our label is telling us that 25 milligrams of medication is dissolved into 20 milliliters of fluid. And our patient is 154 pounds. Now, once again, the first step is always going to be to convert that weight into kilograms if it's not in kilograms. So divide by 2.2. So that gives us 70 kilograms. Now that's where we're going to start out. Do 70 kilograms over 1 to make it a fraction. Looking up top here, we have two actual rates given here. We have 1.5 milligrams per kilogram, and we have 2 milligrams per kilogram. We have to pick one of those to start with. I am going to do the 2 milligrams per kilogram.
So why would you pick that one first?
It really doesn't matter. I mean, you pick either one of them. I picked that one because it's a whole number, not a decimal.
Okay.
So at 2 milligrams per kilogram to do my conversion, so the kilograms will cancel out. So we're now at 70 times 2 milligrams on top. So in milligrams is our unit at this point. Excuse me. Now we do have milligrams to milliliters up here. So I'm going to put milligrams on bottom so they cancel out to milliliters. 25 milligrams and 20 milliliters. So the milligrams cancel out. So we're now going to get our answer here in milliliters that we would administer to the patient. So we got 70 times 2 is 140, times 20 is 2,800 milliliters, over 1 times 25. Was that 112 milliliters? Okay, and that, of course, we have to make sure we qualify that. That is 112 milliliters every 8 hours. Well, we used the 2, which was the larger of the two numbers. So that means what we have here is the maximum dose. To find the minimum dose, we could go through this calculation again, or we could use a titration. What a titration does is it allows us to simply convert that dose. And it's really simple. And there's actually a couple of different ways it can be done. It can be done using a proportion, which is just our maximum compared to our minimum. We had the 1.5 milligrams and the 2 milligrams. But when we calculated the 112, which one did we use? We used the 2. So we put the 2 on bottom with the 12, and now we cross multiply and divide. The 112 on bottom with the 2, and now we're going to cross multiply and divide. So 1.5 times 112 divided by the 2. Which gives us 84 milliliters every 8 hours. So the minimum recommended dose would be 84 milliliters every 8 hours. So that gives us then, for this patient, (84 to 112 milliliters every 8 hours is the recommended dose. Now, where this would come into play is if we're dealing with, you are responsible to double check dosages before you administer, in case a doctor made a mistake or something got transcribed wrong from handwritten notes to a typed order. So let's take a look. Let's say that the doctor orders 50 milliliters Q6H. Remember, that means every 6 hours. And the label is telling us that it is constituted at 5 milligrams in 2 milliliters. And the recommended safe dosage is 3 milligrams to 4 milligrams per kilogram every 8 hours. So there's actually two things here that are going to conflict. One is that we have to do the titration to get the actual safe amount. Then we have this is given in every 6 hours, this is given every 8 hours. So we're going to use the titration for that conversion as well. So let's start out. Well, let's give you a patient here first. How's that sound? So our patient is 143 pounds. So we'll start out by dividing by 2.2 to get, is that 65 kilogram? So there we are, 65 kilograms. So we're going to start with that 65 kilograms. And again, I have to pick either the 3 or the 4. I am in the habit of using the larger of the two numbers. Like I said in the last example, it really does not matter which one you use. I'm going to go ahead and use the 4. So kilograms go on bottom so they cancel out. Milligrams on top. 4 milligrams per kilogram. So we're now in milligrams. And then the label also says 5 milligrams. So I'm putting milligrams on bottom. Concentrated in 2 milliliters. So 5 milligrams over 2 milliliters. So the milligrams are gone. So now we're going to go ahead and multiply this out. 65 times 4 is 260. Times 2 is 520 milliliters divided by 5. So that's 104 milliliters. Now remember, we have to look at the label. That was every 8 hours. So that is 104 milliliters every 8 hours. That is the max. While we're at it, let's find the minimum. So we're going to use that titration. 3 milligrams related to 4 milligrams. So I put 104 on bottom here. I'm going to leave the units off just to save a little time. So 3 times 104 divided by 4 is 78. So that's 78 milliliters every 8 hours. So that is my safe recommended range for this patient. Now there's another way I could have done the titration. What you can do for the titration is you can take the dose times the new amount over what you used for that dose. Let me specify. So this dosage, we had the 104 milliliters per every 8 hours. We could have multiplied. The 104 was calculated off the 4 milligrams. The new would be the 3 milligrams. So it's just 104 times 3/4. Notice it's 104 times 3 divided by 4, exactly like we did in the proportion. Comes up with the 78 milliliters. Well, now we have to do something to adjust their 50 milliliters every 6 hours. So we either need to take our safe dosages and convert them to 6 hours, or convert the doctor's dosage into 8 hours. So that's 50 milliliters. It's being administered over 6 hours, so we're going to put the 6 hours on bottom here. And we're going to change it to the amount for 8 hours. So we're simply going to do 50 times 8 divided by 6. So 66.67 milliliters every 8 hours is the equivalent, what the doctor's dosage is equivalent to an 8-hour dose. Now you can see for what they're giving here, that's actually below the recommended dosage range. Nothing unsafe about it, but it's below the range. So it might be something you'd want to double check. Of course, if it was bigger than the oops, go ahead.
Sorry.
No, go ahead.
So when we do the tests, are you going to be looking for the max and the minimum when we do this?
I might ask you, is this a safe dose?
Okay.
Now, on the test, I wouldn't be looking to see if it was too small, like this example. I'd be looking to see if it was too big. So you'd have to double check to make sure it's not over the maximum. You know, so you'd have to tell me, is this in the safe range or not in the safe range, basically. So you would have to find the range and tell me if that dosage is between it. I may give a problem where I ask you for the minimum and maximum. You bet. Now, of course, I'm not going to talk a lot about it because I'm not the medical expert, but if it's above the maximum, of course, you cannot change the dose yourself. That's where you have to go back and ask somebody to redo their orders or to clarify their orders or whatever. Let's look at body surface area now. Body surface area, BSA, is not as simple to find as weight. You can't just throw them on a scale and convert the pounds to kilograms, or actually now most scales do kilograms anyway. Body surface area has to be calculated in some way. And to do that, we deal with height and weight. If we are measuring in standard units, in other words, height is in inches and weight is in pounds, we can calculate the body surface area in square meters. We want the body surface area in square meters because that's what any of our dosages would be. It was milligrams per square meter. It'll be the square root of the height in inches times that weight in pounds divided by 3,131. So let's say we have a patient who is 71 inches tall and 210 pounds. Their body surface area, 71 times 210 divided by 3,131. So second square root, 71 times 210 divided by 3,131. 2.18. Body surface area, by the way, is also always rounded to 2 decimal places. And that's square meters. So 2.18 square meters of body surface area. If we have the measurements in metric units, in other words, the height is in centimeters and the weight or mass is in kilograms, body surface area in meters squared again is the square root of the height times the weight divided by 3,600. So let's say we have a patient who is 180 centimeters tall and 90 kilograms. Their body surface area will be 180 times 90 divided by 3,600. So square root of 180 times 90 divided by 3,600. 2.12 meters squared. Does that make sense? It's just a matter of having those formulas. Now there is something called the nomogram. What a nomogram is just a chart that you do calculations by lining up 2 numbers. So let's take a look. Well, one of the weaknesses of a nomogram is there's only certain ranges you can use. So I don't believe the ones we even have will even fit on here. Our height is 71 inches and our weight of 210 pounds. I don't believe is even on the chart, but let's take a peek. So here's our nomogram. Yeah, the nomogram, unfortunately, only goes up to a weight of 180 pounds. So 210 pounds won't even appear on the chart. Kilograms only goes up to 80 pounds, so our 90 kilograms is going to be off the chart as well. So let's take a look at a different example. And we're going to calculate both ways. We're going to use the formula and we're going to use the nomogram. So for height, let's say we're looking at 68 inches tall and 160 pounds. If I use the formula for this, these are in standard units, so it's going to be the square root of, it's going to be height times weight, so 68 times 160. Since it's standard units, it's 3,131. So we're getting 1.86 meters squared is that body surface area. So let's look at the nomogram, 68 and 160 here. So our height in inches is all the way over here. So 68, 65, 6, 7, 8 is going to be right there. So that's my 68. The 160 pounds is right here. The body surface area is then given in this column. This rectangle in the middle here, we're going to get to that in a little bit. That's actually a totally separate chart that's been inserted in here because there was extra space. We'll show you how that works. They needed to have the extra distance between the BSA and the height to make the lining up work. So they just put that in the chart just to fill up the blank space. So I'm just going to use a line here. I'm going to format that a little bit so you can see it a little better. So there, you see that line across there. You can see here, this is 1.8 here. This would be 1.9 and 2.0. It's crossing there just below the 1.9. Well, we had calculated 1.86. That's probably about right. I would say the way this looks is probably, yeah, it might be like 1.87, 1.88. But it's in between that 1.85 and 1.9, which is about as close as you're going to get with a chart like this. So let's say we have our height in 140 centimeters and a weight of 70 kilograms. So if we're going to use the formula, this would be the square root of 140 times 70. Then since this is in metric units, it's over 3,600. We get 1.65 meters squared. Now, if you're looking at my calculator, I realize I did drop zeros, but it works out. I just dropped zeros to save a few keystrokes. So 1.65 meters squared. So let's look at 140 and 70 on our nomogram. For centimeters, it's over on this side, so 140 is right here. 70 kilograms is over here, right there. So let's move my line down here. I'm going to move this end down to 70. Let's get a little bit better. Right there. This end I'm moving down to the 140 centimeters. There we go. That's pretty close. The grid lines on my document are messing with me a little bit. But. So you can see that that's coming in just above 1.7. This is 1.6, that'd be 1.7. And we had calculated 1.65. So that one's actually probably a little bit further off. So that's how that nomogram works, is you can just put the line, you line it up. Normally you just take a piece of paper or whatever and line it up across there and see where it cuts across this axis. Okay, what about this chart in the middle? Well, it says for children of normal height for weight. In other words, are their height and weight proportional? If they are of normal height and weight, all we need to use is their weight in pounds. And we can estimate their body surface area. So let's say that we have a child that is 40 pounds. And I don't know even what standard height would be for a 40-pound child. That'd be about a 5-year-old child. But we're just going to go with 40 pounds and say that they are height and weight proportional. They are normal height for their weight. So 40 pounds is right here. That lines up right through there. This is 0.7. This is 0.8. There's 5 gaps between them. So this is doing that scale reading like we did with the syringes. 0.8 minus 0.7 over 5 gaps. So that's 0.1 over 5 gaps. In other words, that's 0.02 for each space on there. So this is 0.7. This is 0.72, 0.74. Looks like that would be about 0.75 meters squared is their body surface area. So the doctor orders you to administer a medication to a patient. The label says 3 milligrams per square meter per day, and that it is concentrated as 5 milligrams in 2 milliliters. We have a patient who is 75 inches tall, 6'3", and 230 pounds. Now the nomogram won't work for this patient, so we're going to have to find their body surface area using the formula. So height times weight, 75 times 230, over, which one are we going to use here? 3131, perfect. So the square root of 75 times 230 divided by 3131. 2.35 meters squared. So that's what we're starting off with here is 2.35 meters squared. We'll put that over 1. Then we're going to use this 3 milligrams per square meter. So square meters on bottom, milligrams on top. 3 milligrams per 1 square meter. Square meters cancel out. Then we got 5 milligrams and 2 milliliters. So we're going to put 5 milligrams on bottom, 2 milliliters on top. Milligrams cancel. So 2.35 times 3 times 2 is 14.1, thank you, milliliters over 5. So we divide that out, we get 2.82 milliliters. And that is per day. So 2.82 milliliters per day can be administered to that patient. Safe dosages do apply to body surface areas as well. Let's say you have a doctor orders 5 milliliters two times a day. The label says, I'll check what I have here, that you can administer 8 milligrams per square meter per day. And that it is concentrated at 50 milligrams and 40 milliliters. The patient is 185 centimeters tall. (95 kilograms). So it should be height times weight, 185 times 95, divided by what number? 3,600 here. So square root of 185 times 95, divided by 3,600. So 2.21 square meters. So we are now going to use that to find the recommended dose for this patient. So 2.21 square meters. Well, this is 8 milligrams per square meter. So square meters cancel. 2.21 times 8. That's 17.68 milligrams. I should have gone another step. I should have done my milliliters all at once, but I'll just do them two separate steps. So my milligrams to milliliters is 50 milligrams to 40 milliliters. Milligrams cancel out. So that the 17.68 times 40 is 707.2 milliliters over 50. So I divide out by the 50. 14.14 milliliters, and that is again per day. Doctor ordered 5 milliliters every 12 hours, or twice a day, I should say. 5 milliliters twice a day.
Yeah.
Does that be? Yeah, you're right. Yeah, you are correct.
Okay.
Yep. Thank you. Yeah, that should be BID twice a day. So 5 times 2 is going to be 10 milliliters per day is what the doctor is ordering. So assuming that 14.14 is a maximum safe dose, the doctor's order is below the maximum. Now we can do titrations with these. Let's say our label says yeah, go ahead. This is what's off the label. So this is what the maximum safe dose per day is. Yep. Yeah, so what the doctor ordered is less than the maximum, so they're okay. So let's take a look. Let's see, the label says 4 milligrams to 5 milligrams per square meter per day. And let's say this is concentrated as 5 milligrams in 4 milliliters. Our patient is 73 inches and 270 pounds. So our first step is going to be to find the body surface area. Standard units, so it's 31. So second square root, 73 times 270 divided by 31. So 2.51 square meters of body surface area. So then we start off with that 2.51 to do our dosage calculation. We're going to get rid of square meters. Trying to go to milligrams. I can either use the 4 or the 5. I'm going to use the 4 this time because I've always used the big one before. So 4 milligrams per square meter. That'll get rid of the square meters. Then we'll do it all in one step this time. We're going to put then the milligrams to milliliters here. 5 milligrams to 4 milliliters. So the milligrams are gone. So we've got 2.51 times 4 times 4, I believe is 40.16 milliliters over 5, which was that divide out to 8.032 milliliters. So 8.03 basically milliliters per day. Now remember, that is the minimum this time because I used the smaller of the two numbers. To find the maximum, I'd use a titration. I'm going to take the 8.03 and I'm going to just multiply by the fraction this time. The number I used was the 4 milligrams per day. I want to convert it to the 5 milligrams per day. So 8.03 times 5 divided by 4 gives us 10.037 or 10.04. So the maximum safe dose is 10.04. Any questions? Which one goes here? Okay. Because basically what this is telling us is this is the minimum recommended and that's the maximum recommended. So then down here, just when I use the 4, the number I get from using the 4 has to be the minimum recommended dose. And then when I do the titration, that gives me the maximum. Or I could go back and I could redo the whole calculation, putting the 5 in here instead of the 4. That should give me the same number here. Is that what you were asking?
Like, how do I know that that's right? Like, would it say what the minimum and
Yeah, well, that's what the label is trying to tell you, is that this is the minimum and maximum recommended dose off the label. Now, I'm simplifying the label because I don't want to get into reading the labels too much. So that's something in a clinical, in a medications class, they would look at exactly what the label would say and how to interpret it off the label. For my purposes, I'm just going to give it to you. They said this is a pretty simple way of stating it, but that's the way I'm going to be giving it to you, is like that. Does that make sense? Okay. Well, that is it for this unit. Remember, next week is our dosage calculation test. The biggest problems that students will miss on that, and I believe we did an example like this, but I'm going to do one right now. Orders GRIX. Oops. And our label says that the medication is concentrated as 25 milligrams in 2 milliliters. I want to know how many milliliters to administer to a patient. So we're starting out, GRIX means, of course, GR is grains, IX is what number? 9. There you go, Roman numerals, yes. That is 9 grains is what that stands for. So the first thing we have to do with something like this before we can do anything else is convert grains into milligrams. Now don't get confused, because a lot of people look at that and they see GR and they think grams. It is not, it is grains. 1 grain is 60 milligrams if you look it up. You may have to look back in the book at the last chapter where we have those conversion charts for you. So now we are in milligrams, and then we can convert with the 25 milligrams and 2 milliliters. So we have 9 times 60 times 2 is what? 1,080 milliliters over 25. So we divide that out, we get 43.2 milliliters. Oops. So that's what you would be administering to the patient, is 43.2 milliliters. Any questions? The 9 grains, that's from the orders. GR means grains, IX is 9 in Roman numerals. Yeah.
On the test, is it going to be a capital I or is it going to be small I like that?
It might be small i's.
Okay.
A lot of times when they use grains, they use small letters, so they might use IV for 4 or III for 3, whatever. A lot of times they'll use small letters when they're mixed with grains.
Right.
Okay, well, that is it then for Unit 3. Next week is our Unit 3 test. There is homework that deals with this stuff. Page 178 through 179, 1 through 21, the odds. Page 184, 1 through 11, the odds. That talks a little bit more about the titrations. Page 188 through 190, 1 through 21, the odds. That is the dosages based on weight. And 196 through 197 1 through 19, the odds. That is the body surface area. You guys have a great week.
You too.
Thanks.
Can you show me how to use this? This is my sister's. And
Okay.
my other one broke, so.
This is the HPs. A lot of times they use a reverse notation.
Okay.
So if you want to do like 8 times 7. Nope. So it's set up. So it still works normal for that. Square roots, however, where's the square root key on this one?
So is it that one or is it?
Here's that one. So you gotta do the brown key, then square root, and then we'll start it. Yeah, so you type in everything else first. So like for that patient that was,
So I was trying, it was getting different.
yeah, so this is 73 pounds, or 73 inches, 270 pounds. You're gonna do 73 times 270 divided by the 3131. It equals. Then it's just brown key square root.
Oh, okay. That's where I was having problems.
This is set to round off. These are usually for financial.
Yeah.
These are always set to round off to keep to the nearest penny, so 2 decimal places.
Okay. Okay, perfect. Thank you.
You bet.